The question before us, a body starts from rest and moves with uniform acceleration of 6 meters per second squared. So if you look at that question, you see that our initial velocity is given to be 0 since the body starts from rest. And then the acceleration is 6 meters per second squared. As seen, we're extracting the parameters from the equation so we can solve correctly. Then what distance does it cover in the third second? So the distance is in between the third second and the second second. I hope you get that. Between the third second and the second seconds. If that is the case, we can use second equation of motion. I hope you get that. Because of the distance. So we can say S is equal to UT plus half AT squared. This formula suits our parameters so that we now have our distance to be the distance of the third second negative the distance of the second seconds. By substitution, we have S is equal to half A into T of 3 squared negative T of 2 squared. So that our distance is equal to half by substitution multiplied by 6. 1 over 2 times 6 into 3 squared negative 2 squared. Close bracket. Using the process of board mass, we can say S is equal to half multiplied by 6 into 9 minus 4. So that S is equal to half multiplied by 6 into 5. So that our distance is equal to 6 divided by 2. Our distance is equal to 6 divided by 2 into 5. 3 multiplied by 5, which is equal to 15 meters. Take note of that, our SI unit. From the equation above, you see that the body accelerates uniformly from rest. So, our initial velocity is given to be 0. Is that clear? Because he accelerates from rest. Acceleration is given to be 3 meters per second squared. Our time is given to be 8 seconds. So we are to calculate the distance covered during this acceleration. And the distance covered, we can apply second equation of motion because of the distance there. We have UT plus half AT squared. By substitution, 0 multiplied by 8 plus 1 over 2 multiplied by 3 multiplied by 8 squared. So that our distance is equal to 0 plus half multiplied by 3 multiplied by 64. So that our distance is equal to 3 multiplied by 64 divided by 2. So that our distance is equal to 192 divided by 2. So that our distance will now equal 96 meters. From this question, the particle starts from rest. So our initial velocity is 0. Anytime a body begins from rest, initial velocity is 0. Take note of that. Then acceleration is given to us to be 0.5 meter per second. Always look at the SI units. They will guide you in solving physics equations. Then our time is given to be unknown. Our distance is given to be 25 meters from the equation. So our velocity, which is final velocity, is unknown. Hence, we can use third equation of motion. V squared is equal to U squared plus 2AS, so that V squared is equal to 0 squared plus 2 into 0.5 into 25, so that our V squared will equal 25 so that taking the square root of both sides, you have V will now equal the square root of 25, so that our V will now equal 5 meters per second. Our final answer, take note of that. Let's take a look at the next question. A particle starts from rest. Initial velocity, as usual, will be 0, with a constant acceleration of 0.5 meter per second squared. Always look at the SI unit. They will guide you in answering physics questions. Now, we are asked to find t, which is a time taken to cover the distance of 25 meters. So we can either use equation 1 or the second equation of motion. Whichever equation you choose to use is going to be useful in answering this question. Hence, from the first equation of motion, V is equal to U plus AT, so that 5 will now equal 0 plus 0.5 multiplied by T, so that 5 will equal 0.5 T. Divide through by 0.5, 0.5 will cancel 0.5, so that T will now equal 5 divided by 0.5, then T equals 10 seconds. Take note of that. Or, if we are to use the second equation of motion, which states S is equal to UT plus half AT squared, by substitution, 25 is equal to plus 0.5 T divided by 2. I've skipped some steps. So, remember that it is T squared, so that 25 will equal 0.5 T squared divided by 2. If you cross multiply, 25 multiplied by 2 will equal 0.5 T squared. So that 50 will now equal 0.5 T squared. Divide through by 0.5, we have T squared to be 50 divided by 0.5, and the square root of 50 divided by 0.5 will give you T, which equals 10 seconds. Take note of that. Another question is before us. How far will a body move in 4 seconds time if uniformly accelerated from rest initial velocity at the rate of 2 meters per second squared? Now, if you look at it, that distance is equal to unknown. How far? Distance. Time is equal to 4 seconds. Initial velocity 0 meter per second is equal to 2 meters per second squared. So that if we use second equation of motion, U plus S is equal to U T plus half AT squared, so that S is equal to 0 multiplied by T plus 1 over 2 into 4 squared, so that S is equal to 0 plus 1 over 2 multiplied by 2 multiplied by 16, so that S will now equal 32 divided by 2, so that S is equal to 16 meters. This question, a car takes off from rest. Initial velocity is equal to 0 meter per second. A distance of 80 meters. Distance 80 meters in 10 seconds. Time 10 seconds. Calculate the magnitude of its acceleration. So our A is equal to unknown using S is equal to UT plus half AT squared. We have AT is equal to 0 multiplied by 10 plus half into 9 into A into 10 squared. So that 80 is equal to 0 plus half into 100 multiplied by A. So that 80 is equal to 100A divided by 2, cross multiplying, so that you have 80 multiplied by 2 is equal to 100A. Divide through by 100. Is that clear? So that you have 160 divided by 100 is equal to 100 divided by 100. 100 cancel 100. A is equal to 160 by 100, which gives you 16 divided by 10 is equal to 8 divided by 5. So that A is equal to 1.6 meter per second squared. Final answer. This question states that a bus traveling at 15 meters per second accelerates uniformly. So our U is equal to 15 meters per second initial velocity. Our acceleration is equal to 4 meters per second squared. Then our distance is equal to unknown. Time is equal to 10 seconds. If we use the second equation of motion, we now have S is equal to UT plus half AT squared. So that S is equal to 15 multiplied by 10 plus half multiplied by 4 multiplied by 10 squared. So that S is equal to 150 plus 1 over 2 multiplied by 4 multiplied by 100. So that S is equal to 150 plus 400 divided by 2 plus 200. So that our distance will equal 350 meters. Next question. A body starts from rest. Initial velocity 0. Acceleration 5 meters per second squared. So that our time taken by the body is unknown. Then our distance is given to be 1 kilometers. So that 1 kilometers is equal to 1 multiplied by 1,000. So that our distance is equal to 1,000 meters. If we substitute that into the second equation of motion, UT plus half AT squared, where 1,000 is equal to 0 multiplied by T plus 1 over 2 multiplied by 5 multiplied by T squared. So that 1,000 will equal 5T squared over 2. When you cross multiply, 1,000 will multiply 2 and is equal to 5T squared. So that 2,000 is equal to 5T squared. Divide through by 5, you have T squared to be 2,000 divided by 5. So that T squared is equal to 400. Square root of 400 will give you 20 seconds. Next question. A body accelerates uniformly from rest at 2 meters per second squared. Acceleration is 2 meters per second squared. Initial velocity is 0 because it accelerates from rest. so that our distance is unknown, our time is 10 seconds. If we use the second equation of motion, s is equal to ut plus half at squared, you have s is equal to 0 multiplied by 10 plus half multiplied by 0.5 multiplied by 10 squared, so that s is equal to 0 plus 1 over 2 multiplied by 0.5 multiplied by 100, so that our s is equal to 0.5 multiplied by 100 divided by 2, so that our s will now equal 50 divided by 2, and our s will now equal 25 meters. Our last question for today: a body accelerates uniformly from rest, so initial velocity 0 meter per second. Then our acceleration 2 meter per second squared. Our final velocity unknown. Distance 9 meters as given. So using v squared is equal to u squared plus 2as. By substitution, we have v squared is equal to 0 squared plus 2 multiplied by 2 multiplied by 9. So that v squared is equal to 0 multiplied by 4 multiplied by 9. So that v squared is equal to 36. And the square root of 36 will give you 6 meters per second as our velocity. Take note. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.